Okay, so now that we're talking about biomolecules, it's really important to talk about something called chirality. So we'll talk a little in a minute about what chirality is, but this overall is a type of isomer that you'll see. So we've talked a lot about isomers in terms of constitutional isomers, conformers that are not really even isomers, right? They're the exact same molecule, but constitutional isomers and then cis-trans isomers are the main ones we've talked about. So just as a reminder, a constitutional isomer could also be called a structural isomer. It has the same molecular formula, but different connectivity. You physically have to like tear things apart, put them in completely new places. So examples of this are like, we can have ethanol and dimethyl ether, and both of these have the molecular formula C2H6O, but they're completely different kinds of molecules, right? Or we could have, for example, like a ketone and an aldehyde. These are completely different molecules, but they both have the same molecular formula. A new kind of version, we're going to introduce this new word called stereoisomers. So when we've talked about cis-trans isomers, they're a version of stereoisomers. So stereoisomers is kind of the big umbrella phrase for these types of isomers, and there's a couple different types within that. So we talked about cis-trans isomers. These are stereoisomers, which mean that they have the same molecular formula, but different connectivity in terms of spatial arrangement. So they're all connected to the same types of things. So like when we had our cis-trans isomers, those are the exact same chemical formula. Every atom is bonded to the same atom for both of or same type of atom for both of the molecules, but you had to change the geometry of the atoms in space. So a cis-trans isomer is a version of a stereoisomer, and we're also going to learn two new versions, which are called enantiomers and diastereomers. So we'll define those even further later, but know that they're an umbrella term. The umbrella term for them is stereoisomers. So the same connectivity in terms of what's bonded to what, but they're in a new orientation, new geometric arrangement. So I said this word chiral. What is chiral? The definition of something that is chiral is that it has non-superimposable mirror images. So for example, you see these shoes. So those, if you take the mirror image of one shoe, so if you put a mirror right next to it, you can see that the other shoe is the exact mirror image, but if you put them on top of each other, they're not the same, right? They're not exactly the same shoe. I mean, there's probably some shoes out there. I know like girls, there's some like ballet flats and stuff. Actually, my ballet shoes when I did ballet growing up, those were non-chiral because those shoes didn't have, they did superimpose. So let's go ahead and define achiral and then go back and talk about more examples. So achiral or achiral things are where the mirror images are superimposable. So it means that they're the same. Okay, so the big example that everybody likes to talk about for chiral versus achiral are your hands. So right now I have a ring on, so maybe we'll take that off just to show it, but your hands are chiral. So if I put my hand in a mirror like this, for example, or like this, doesn't matter, but if I put the mirror right here and right next to my hand, my other hand is the mirror image of my left hand is the mirror image of my right hand. My right hand's the mirror image of my left hand. However, if I now take my two hands and put them on top of each other, they don't match, right? My thumb isn't on the same place for each of my hands. They are mirror images of each other, but they do not overlap to form the same thing. Achiral things, when you take the mirror image and put them on top of each other, they're the exact same thing. So for example, another word I wanted to write down with this, sometimes chirality or chiral properties of objects can also be called handedness. That's kind of a classical way of describing it, having two hands to something, one right-handed, one left hand, showing the two different versions of it. So everyday things that are chiral, you guys can come up with some ideas of some shoes, hands. I was thinking about my mask is actually achiral. So I was holding this up. If I do a mirror image of my mask, because it's symmetric on either side, this is now achiral. But yeah, there's lots of examples of this in the world in general, chiral and achiral types of things. And so when we look at organic molecules, or eventually we'll look at biochemical molecules as well, but organic molecules can also be chiral. So if I take this molecule here, this, you see how we have a carbon atom in the middle. We almost always will have chirality at a carbon atom, but not always, but almost always. And it's easiest to explain with carbon atoms to start with. It's also just the most common, but if I have this carbon atom here, you can see this iodine is coming out towards me, bromine is kind of going out to the left, chlorine is going back into the plane of the paper, and then hydrogen's going straight up, right? So, or hydrogen's kind of coming out at us, but straight up. Okay, so if I put a mirror, then we see this second molecule here. So you see that iodine is now, it was going to the right a little bit, now it's going to the left a little bit. Chlorine was going to the right, now it's going to the left. Bromine was going to the left, now it's going to the right. Hydrogen's going up. So you see that mirror image. Now, if we take those two images, we try and put them on top of each other and align everything so that it's lined up. So typically what I like to do is pick one bond and overlap those and then see if the rest of those atoms overlap. So you can see here that both the carbon hydrogen bonds in each of these molecules are pointing up. So we'll start with those. See if line up the carbon hydrogen atoms and then see if everything else overlaps. So you'll see that carbon hydrogen overlap and carbon iodine overlap for both molecules, but now the side that the chlorine is on and the side that the bromine is on is switched. So these are chiral molecules. They have a handedness to them. They're like, one of them is the right hand and one of them is the left hand, and they can't overlap. So what these are called, let's go ahead and label these as mirror images. So they're non-superimposable, so they are chiral. So what these are called is enantiomers. So this is called enantiomers when you have two molecules that are non-superimposable, they're chiral. The relationship is called enantiomers. The molecule itself, if I just gave you this very first molecule here and said, is it chiral or achiral? We're not saying enantiomers because enantiomers is the actual relationship. A chirality, or having a chiral molecule, is a property of a single molecule. So this molecule is chiral because if you take the mirror image of it and overlap them, they are non-superimposable. However, the relationship between those two molecules that we made with the mirror image, the relationship is enantiomers. We're going to stop this video here so that we're not making the videos too long. And we'll jump back in and talk about enantiomers and then its kind of cousin diastereomers in our next video.